Welcome back. Now that we know how to find our p hat and q hat, we know how to find our best point estimate of the population proportion. So our best point estimate of the population proportion is p hat. And now we need to look at the error. When we find error, the minimum error, we're going to use this formula. It's going to be the critical value multiplied by something. So our critical value is the same as it has been before. Z alpha over 2 is still our critical value. And these are the same as they were before. We're going to population proportions when we look at samples of them, when we use the central limit theorem, we're going to find that they have a normal distribution. So we can go back to using Z values as our critical values instead of T. So this process will follow the normal distribution. So we'll have Z critical values. And then we have the square root of p hat q hat divided by n. So when we look at our point estimate plus or minus our error, that's p hat plus or minus Z alpha over 2 times the square root of p hat q hat over n. Our rounding rule for proportions, we are going to round all proportions to 3 decimal places. That means your proportions will be either, your p hat will be 0.3 decimals or 1 decimal if you represent it as a percent. So that's our rounding rule. You need to make sure that you carry 3 decimals. All right. We're going to look at an example here. A sample of 500 nursing applications included 60 from men. Find the 90% confidence interval of the true proportion of men who applied to the nursing program. Okay, so the first thing I need to do is identify my key information. So key information, when I'm trying to make a confidence interval estimate of proportion, things that I'm going to need. I need to get my sample size, which is 500. I need my number of successes, which is 60. I need my confidence level, which is 90%. So based on my n and x, I can get p hat. P hat is going to be x divided by n, or 60 divided by 500. 60 divided by 500 gives me a p hat of 0.12. That's important. Q hat is going to be 1 minus p hat, so 1 minus 0.12. It's going to give me 0.88. So I now have p hat, q hat. N also is going to appear in my formula, and I need my critical value Z. We can find our critical value by doing inverse norm alpha over 2. Or I can just know what it is. So my alpha over 2 is going to be 0.05. So I'm just going to go through and do this here, 0.05. Or let's go through this. 1 minus 0.9 divided by 2. And that gives me 1.645. So my critical value is 1.645. Now that I have my critical value, my point estimate is p hat, and that is 0.12. My error is E, and that was Z alpha over 2 times the square root of p hat q hat divided by n. We got that on the previous page of notes right here. That's our error equation. So now that I have my error equation, I'm going to go ahead and fill this in. So my critical value is 1.645 times the square root of p hat, which is 0.12, q hat is 0.88, divided by n. N is 500. So I'll pull out my calculator, 1.645 times the square root of 0.12 times 0.88 divided by 500. My error is 0.024, 3 decimals. My p hat only had 2 decimals, but it was exact, so the third decimal is actually going to be a 0, 0.120. So my estimate is going to be p hat minus the error is less than p is less than p hat plus the error. So that's 0.12 minus 0.024 is less than p is less than 0.12 plus 0.024. So that's going to be 0.96 or 0.096 is less than p is less than 0.144. So in words, we can write this as we are 90% confident that the true population proportion for the number of nursing applications from men is between 9.6% and 14.4%. This is my conclusion. We are 90% confident that the true population proportion for the number of nursing applications from men is between 9.6% and 14.4%.